Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone. I hope all of you are doing very well. So this week we are going to complete tutorial sheet number 3, which is part of high voltage engineering. So last week we did question 1, 2, 3 and question 4, and this week we will complete this tutorial with question 5, 6 and 7. So let's start it with question number 5. So in this question, he asked us to calculate the number of electrons formed in an electron's avalanche, which traveled a distance of 1.5 centimeter in a uniform filled gap between two parallel plates. And he provides that in air at given field, the values of ionization, photoionization, and attachment coefficient are the ionization he gives us as 7.4 and the photoionization as 5 and the attachment coefficient as 2.4. And he gave us the electron avalanche was started by an electron flash of 100 electron. So he gave us in this question the number of electron as 100 electrons. So let's move on to the answer sheet to see how can we calculate the number of electrons formed. So as I said, in this question, he gave us so many values. He gave us the distance as 1.5, the ionization 7.4, the photoionization 5, the attachment coefficient as 2.4, and the number of electrons as 100. So he asked us to find the number of electrons formed, which we called it as N. Okay. So from this formula here, NBD, it's equal number of electron into E to the power net ionization into this distance. We can calculate the required N here. So before we started using this formula, we have to find all the value in this formula. So the number of electron, it's already given in the question, and the distance also it's already given in the question. So we need to find the net ionization. How can we find the net ionization? It's easy. By using this formula here, we can get the net ionization. So the net ionization, it's equal the ionization plus the photoionization minus the attachment coefficient. All this here, it's already given in the question. So the ionization, it's giving as a 7.4 and the photoionization, it's giving as a 5 and the attachment coefficient, it's giving as 2.4. By using your calculator, you will get the net ionization will be equal 10. Okay, so now since we find the net ionization, we can easily use this formula by substituting the value that giving in the question, which is the number of electron and the distance, and using the net ionization that we just calculated. Okay, so by substituting the value, we will get the formula as 100 into E to the power 10 into 1.5. And if you use your calculator, you will get the answer as a 326.9 into 10 to the power 6 electron. So we already found the required of this question. So the required of this question, the number of electron formed, it's equal 326.9 into 10 to the power 6 electrons. So if you have any doubt in this question, just write your doubt down and I will explain everything, okay? So let's move on now to the question number 6. Question number 6 will be very easy. It's exactly the question number 5. So let's see what he wants us to calculate. Here he wants us to calculate the value of secondary ionization coefficient that fulfill Townsend criterion of breakdown in a uniform gap of 2 cm width. while stressed by uniform field corresponding to net ionization factor of 8. So here in this question, he wants us to calculate the secondary ionization coefficient. Also, he gives us the value of the distance, which is 2 centimeter, and the net ionization, which is 8. So let's move on to the answer sheet to see how can we solve this problem. Okay. So the required to find the secondary ionization breakdown. We have the formula of the secondary ionization breakdown. The formula will be like this. Gamma BD it's equal 1 divided by e to the power net ionization into distance. So here in this formula, the value of the net ionization it's already giving, and the value of the distance also already giving in the question. So we only need to substitute the value of the net ionization and substitute the value of the distance, and using our calculator to see the value of the secondary ionization. So now let's see how can we calculate this. So by substituting the value, the formula will be 1 divided by e to the power 8 into number 2 into 2. Okay, so the secondary ionization will be equal 1.125 into 10 to the power minus 7. If you get this answer, your answer is okay. And if you want make your answer look better, you can use by this way. Be brushing inch in your calculator, you will get the answer as 112.53 into 10 to the power minus 9. So if you write this answer, you will get the full mark in the question. Okay, so if you have any question in this any doubt in this question, you just write down your doubt and ask me in the end of this session. So now let's move on to the last question in this tutorial, which is question 7. Okay. In this question, he gives us a voltage of 12 kilovolt has been applied to a parallel plate's air gap of 1.2 centimeter width. So the distance is 1.2 centimeter. In the table, the ionization and the attachment coefficient are given as a function of electrical field E. Assume the photoionization to be constant and equals 5. So in this question, he told us to assume the photoionization as 5. And he give us the value with so many numbers here. He give us a table with so many values here. Sorry. So the first required, he want us to calculate the number of electrons reaching the anode due to avalanche initiated by one electron at the cathode. So the number of electron here give us as a 1 electron. If the secondary ionization is equal 10 to the power minus 7, he asks us here, will breakdown take place or not? So, will the secondary ionization in the breakdown situation will take place or not? So, let's move on to the answer sheet to see how can we use this table. So in the beginning of this on each question that I solve, I write the giving value to make it as a reference for me. Okay, so the volt he give us as a 12 kilovolt, the distance is 1.2 centimeter, and the photoionization it's giving as a 5, and the number of electron it's 1 electron. So the value of the electric field it's giving in the table, the value of the ionization it's also giving in the table, also the attachment coefficient value are giving in the table. Okay, so the first required, he asked us to find the number of electron n. So let's move on. How can we find n? We cannot find n now because we have to find the net ionization. And the net ionization, if we don't know the value of the ionization and the attachment coefficient, we cannot get the value of the net ionization. Okay, so since electric field it's equal volt divided by distance, so we have the value of the volt and we have the value of the distance. So the electric field it's equal 12, which is the volt, divided by 1.2, which is the distance. It's equal 10 kilovolt. Now from here, from this value here, 10 kilovolt, we will go back to the question and see electric field here. It's giving, we calculate it and we get the answer as 10. So now we can know the value of the ionization, which is 11.4. So the ionization, it's under the 10 column, it's 11.4, and the attachment coefficient will be 1.56. So this the way we use the table. So if the electric field is 9, then the ionization will be 6.8, and the attachment coefficient will be 1.26. So since we get the answer as 10, the electric field it's equal 10. So the ionization is 11.4 and the attachment coefficient is 1.56. So let's go back to the answer sheet to complete this question. So since we get the value of the ionization and the value of attachment coefficient, and we already get the value, it's already giving in the question the value of the photoionization, we can easily find the net ionization. So the net ionization, it's equal ionization, which is 11.4, and plus the photoionization, which is given in the question as a 5, also the coefficient, the attachment coefficient, which is 1.56. So the answer, the net ionization will be equal 14.84. So now let's move on to the first required. Since we found the value of the net ionization, we can find the first required n, which is using this formula. N breakdown is equal the number of electron into E to the net ionization into distance. So the number of electron, it's already given in the question as 1, and the net ionization we just calculated and we get the answer as 14.84, and the distance it's giving in the question as 1.2. So we only need to substitute the value in this formula. When we substitute the value in this formula and use our calculator, we will get the answer as 54.189 into 10 to the power 6 electrons. So now we already finished the first required in question 7. Let's move on to the second required in this question. The second required, he give us the secondary ionization as 10 to the power minus 7. And he asked us, will breakdown take place or not? So he asked us, will the secondary ionization in the breakdown situation will take place or no? Let's see. Let's find out how can we solve this problem. So from this equation, the secondary ionization breakdown formula, it's equal 1 divided by E to the net ionization into distance. So we have all the value here. So we know all the value here. So only we need to substitute the value in this formula, and immediately we can get the answer. So by substituting the value in this formula, it will be 1 divided by E to the power 14.84 into 1.2. So if you use your calculator, you will get the answer as 1.845 into 10 to the power minus 7. So since the secondary ionization greater than the secondary ionization in the breakdown situation. So the secondary ionization breakdown will take place because the secondary ionization is greater than the secondary ionization in the breakdown situation. And this is the end of this session today. And if you have any doubt, any misunderstanding in any part, in any question, you can ask me, and I will be happy to explain everything to you guys and clarify any doubt that you have. Thank you so much.